All right, this next trick is again something that you've kind of seen come up over and over again. In fact, we did a bunch of these in 7.2, but what do you do when you end up with a compound fraction? So in other words, a fraction within a fraction. So when I look at this identity, on the right-hand side, I could change that into 1 over sine x, but that's as simple as I can make it. So I'm going to work mainly on this left-hand side. So the first thing I'm going to do is change everything into sines and cosines. So I've got cos x plus sine x times tan x is sine x over cos x. Okay, all over sine x times 1 over cos x. All right, so now let's make that simpler. I've got cos x plus sine squared x over cos x, all over sine x over cos x. So this is the point where you'll recognize that you have a compound, or some textbooks call it complex fraction. In other words, you have a fraction within a fraction. So we've got one here, and we've got one here. So to get rid of these fractions within fractions, you have two options. Option number one, you can treat the numerator in brackets divided by the denominator. So what you would do is create a common denominator in your numerator, and then you'll have a fraction divided by a fraction, and you can flip and multiply. Or you can multiply by the lowest common denominator. What I mean by that is that the denominators within the denominators, we have a cos x and we have a cos x. So my lowest common denominator of my compound fractions is cos x. So I'm going to multiply this fraction by cos x over cos x. This will allow me to destroy the denominator. So I'm going to take this cos x and I'm going to distribute it through the numerator and the denominator. So what's going to happen when I do that? Well, I will end up with cos x times cos x, which is cos squared x. And then I'll end up with cos x times sine squared x divided by cos x. So the cos x's would simplify, and I'd be left with just sine squared x. And then in my denominator, sine x over cos x times cos x would leave me with just a sine x. And then I can see that I have a glaring identity. Cos squared x plus sine squared x is 1 over sine x, and I'm done. So if this doesn't make sense to you, right, the alternative is that you do what I first talked about. You've got cos x plus sine squared x over cos x being divided by sine x over cos x. So you can rewrite it as a numerator being divided by the denominator. Now at this point you could flip and multiply, or I could create a common denominator in my numerator. So I'm going to create a common denominator of cos x. So I'm going to multiply this fraction by cos x over cos x to get cos squared x plus sine squared x. Ooh, that came out ugly. Plus sine squared x. And I'm going to flip the second fraction and multiply. So cos x over sine x. And here I'll notice that I can simplify. Cos x divided by cos x is 1. And then I'm also going to recognize my glaring identity that cos squared x plus sine squared x is 1. So then again, what am I left with? Well, I'm left with 1 over sine x. So however you want to clear your compound fractions, whether you want to multiply by 1, meaning multiply by the lowest common denominator divided by the lowest common denominator, or you want to treat it as your numerator divided by your denominator and then flip and multiply, totally up to you. So here's another one to try. So pause your video and give this one a go. So hopefully you did, okay? And so right-hand side is as simple as it can get. Left-hand side, I'm gonna make this 1 over sine x, all over sine x over cos x plus cos x over sine x. Okay, so my denominators, I have a sine x, a cos x, and a sine x. So my lowest common denominator is going to be cos x sine x. So I'm going to multiply my numerator. I'm going to write it as sine x cos x, and my denominator. So if I don't want to show it, you know in the last example I showed it as a fraction and then I didn't actually rewrite it. A lot of people find it easier if we rewrite it so that every term is getting multiplied by sine x cos x. That way you can clearly see sine x divided by sine x is 1, cos x divided by cos x is 1, and sine x divided by sine x is 1. Right? So it makes it maybe a little bit easier to manage. So in the numerator, we end up with 1 times cos x, or just cos x. And then in my denominator, I've got sine x times sine x is sine squared x, and then cos x times cos x is cos squared x. Then you should see your Pythagorean identity that sine squared x plus cos squared x is 1. So that's going to simplify to just cos x. And hopefully you're liking these, you know, again, like a big yay, I did it, something along those lines when you feel that sense of accomplishment. You know, the nice thing is with trig identities is there's never a question if you did it. Well, I guess there is a question if you did it right, but if you can turn left side into right side without breaking any math rules, right, as long as you know your math rules, then you know that you've done these right, which is a great feeling.